Um, Holly, would you be willing to do some of the aiming and shining? Hasn't shown up once I start moving around a bit. Thank you. All right. So, first off, yours is the first exam that I'm giving. So that's 1 to 320 right here in the same back cave that we've been having class all semester long. Oh wait, sorry, 1 to 3:20. I'll have an office hour the hour before. So 11:50 to 12:50 approximately. Does that mean you won't be able to catch me earlier? I don't know. But definitely that hour, I'm protecting that hour for questions from this class. If no one shows up and some other student from another class of mine shows up, but none of you are here, then I'll answer their questions. But you have first priority if you show up with questions. Plus, you can be asking at the MLC or emailing me throughout the weekend. Before I forget, tomorrow I'll be working on final answers, not showing the work, but just giving the final answers to the questions on the practice. Anyway, after your test, when you're done at 3:20 or so on Monday afternoon, after that, my focus will go to the other two classes, actually 3 classes, but 2 of them are just 2 different sections of the same class. From then on, I don't list anything because what I do during the finals week is I disappear. I magically come up with grades by throwing them down the stairs, and whichever one hits the highest stair gets the A.
Oh, yeah.
No, just kidding. No, I will be alternating between working my butt off and resting, and then working my butt off, etc., and then making my decisions on what would be, if some curving is needed, what's going to be a fair, consistent way to do that. So I ask that once you're done, whether you're feeling good or bad, that you give me the time to do the grading and to have the peace of mind, the clearness of mind to make good decisions. So I'm not going to be around the building much after Tuesday, and if I get an email, I'm probably going to be very slow to respond. You already have an idea of how long it is, but remember there's extra credit. So actually, let's say you're trying to get 183 points. Instead of 183 out of 200, there's actually 220 available. So it's actually a little easier to do that. But whatever it says for you on Blackboard to get an A, double that. To get a B, double that, because that's a percentage on Blackboard, and it's out of 200 points. Shoot as much as you can for that goal, then let me do the worrying about whether I can say you were close and whether I can bump you. You do as much as you can to get towards that goal. And then give me the peace of mind. I have to turn in the grades for all my classes by the following Monday, no later than 5 p.m. So give me the time and the peace of mind to do that grading and make good decisions. Abel, I've got something to hand back to you here real quick. There's the attendance sheet. Go ahead and wait right there. Excuse me. There you go.
We'll do it that way.
That'll work a little better. All right. What else then? So, I hope that doesn't sound rude. I just want to be able to make sure I get it done and that I can make good decisions about what letter grades to turn in. So,
Everybody get the name.
well, you know the numbers. Anyway, I keep getting reminders from the provost's office and from IT to tell you you can do evaluations. It's kind of weird. They've been telling me for about 4 weeks, and they leave them open until the Sunday after the exams.
Yeah.
So there's still 9 days where you can say Sarge is a jerk, or Sarge is great, or somewhere in between. It probably closes up at 5 p.m. on the following Sunday. So here's my announcement of it, instead of trying to remind you every single class and making a pain out of myself that way, that you can go to a link and pause. It tells me no other information besides the fact that 2 of you have already filled one out. I don't know who or what was said. It's anonymous, and they don't let me see any results until after I turn in the grades.
So who actually gets to see these?
Department chairs, dean of the CSM, maybe the provost. So whatever you said it was me, you need to go back and change it.
No, it was not my other professor.
I see.
Who's also the department chair? Good stuff.
Okay.
No, they don't see your name.
They don't know who wrote it.
Oh, thank God.
Let me open up the electronic copy here of the practice questions, but in the meantime,
Are you going to put up a key for the?
gonna be working on posting that tomorrow. It'll just be the answers, not the work.
Alright, that's fine.
I want you to see here, there's a formula sheet that's been updated since exam 3,
So that one's not gonna.
so it actually goes back.
That one's not gonna put little stupid blocks and stuff.
Nope. The only reason I think that happens is either transferring from one computer to another was the issue, or it might have been this. Let me try something here. I'll show you real quick a possible reason it happened. Okay, get it. It may have been because of changing a font. I may have done that just before printing. But I will be looking in advance before I bring them down and all that. So, you've got stuff that's going back to chapter 3 and 4, up through, what was our last chapter, 19? The 2 sample stuff. So we've got all that in between, and then you're going to have table A, table B, and table C. In terms of what you can ask today, there's 1 or 2 things I want to let you know about, some particular questions, and then I think I'll open it up to whatever you've looked at already or are seeing in the next few minutes. As I put in my announcement when I posted this, in the almost 6 years that I've been here now, most of those semesters teaching statistics, we've had a group written final by everyone that's teaching Math 156. I didn't teach it in the fall, and our main coordinator of the instructor group has been on sabbatical, so all of a sudden I asked a few weeks ago one of our other people that teaches it often, are we going to have any meeting to write up a final? And she said, no. I'm like, okay. I don't know what the reason is for it, but as I put in the announcement, it's going to be pretty similar to this. This is actually one that was given in the past, and I'm going to pick another one that was, from the past and make a few changes, because I don't want them to come back to me and say, oh, well, even though we didn't write it together, you gave something that was either too hard or too easy compared to what we gave. So if I can say, hey, I didn't make very many changes to a past one, I'm covering myself. So again, you know what kind of length it's going to be from this. This one was, I think, from a year and a half ago, and they surprised me by wanting to ask a type of question that they had never put on there before. So I had to rush with that particular section and teach them something that I had skipped over in chapter 4 or chapter 5. And it deals with these formulas. I think when we covered it, that I did show you, but I never asked a homework or quiz or test question. So if we turn the practice problems to number 5 on page, I didn't put page numbers on there. I think it's page 4. Let's see when I move to page 4. There we go. Professor Krugman's economic course, the correlation between students' total scores prior to the final examination. Blah, 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 blah. All right, let's see. I think this will probably pick it up pretty well. We'll take a look at what's given here. We have a correlation, assuming a linear relationship between the scores prior to the final and their scores on the final, with 0.5 as the correlation. Pre-exam totals for all students in the course have a mean of 280. Let's see here. And a standard deviation of 40. And although Professor Krugman knows that the final exam scores have a mean of 75, and a standard deviation of 8, poor Julia's had her exam lost. So after scoring it and finding out the mean and the standard deviation, the paper has disappeared before it could get entered into the book that it needs to be entered in. So he knows that she had a total before the exam of 300. She'd like to predict her final exam score from her pre-exam total. Let's take a look at the formulas we have at the top of the page and see if we could figure out whether we've got enough information. So he's going to assume that what would lead to what? What would be our explanatory and response variables here? We've got information about stuff on the final exam, and we've got stuff about their total scores before the exam. So what should be the explanatory and what should be the response? Which one comes first in time? Okay, that pre-exam total. So in other words, this stuff about before the exam, that's our information about X. We want to see then, do we have the standard deviation for X? Do we have the mean for X? Is what that's indicating. And if we've got that, what about the standard deviation and the mean for Y? Well, that's our final exam scores. As our response variable. R is the same as the R we used in chapter 4 and 5, and we were given it was 0.5. Well, check this out then. If I use the first formula before the second formula, .5 we've got standard deviation for Y. So standard deviation of the final exam scores. What's that? 8. Okay. And the other standard deviation we were given was about the pre-exam totals of 40. Without opening up the calculator here, I know that reduces to 1/5. So what's 1/5 of 0.5? An easier question is, what's 1/5 of 5? 1. And so 1/5 of 0.5 should be 0.1. Questions so far? I went for that formula before this one because to make my prediction about her final exam score, I was going to need the B in there. Now, let's see here. Now that we've got B, and what's our Y bar here? 75. It's the mean of the final exam scores. X bar is the 280. Okay, so 75 minus 0.1 for B times the 280 for X bar. That should be 75 minus 28. And what's that, 47? Correct? 75 minus
Yeah.
28, 47? Okay. Okay. What those are coefficients for our linear regression equation, the equation of our line. The person who prepared this is the one that's on sabbatical. He prepared the formula sheets, and he does what the authors do, where I think if we scroll down a little further, we might have something else about regression. No? Okay. Well, you might remember from chapter 4 or chapter 5. We're used to y equals mx plus b. Or you could have ax plus b equaling y. But for some reason in the textbook, the way the a and the b are getting used is reversed. We're used to b standing for the y coordinate of the y-intercept. They've got it reversed. Therefore, our b in this case is our slope, 0.1. And a, 47, is the y coordinate of the y-intercept. That should be enough now to figure out what her score on the final might have been, knowing that she had 300 points before the exam. Plug that in for x. Calculator could do it all at once, but if you have to break it down, multiply then add. So it looks like that's going to be 77. Questions?
So do we have to like actually work out the math? Because doesn't it just say to find an equation? Or
Let's look back at what the question is.
okay.
As for the sketch, really I didn't like this question when we asked it about a year ago, because what are we going to do? Maybe if we put some numbering on there, like, well, if this is 0, 0, then make this something like 300 0 for her input, and then make that something like 0.77 for her output. I'm mainly going to be looking for an increasing line that has a y-intercept above 0, because the y-intercept is 0.47. That's about all I'm going to be looking for then, is do you have the y-intercept, if it's positive, above the origin, if it's negative, below it. If the slope is positive, then draw an increasing line. And if it's a negative slope, have a decreasing line. Part C has the part that I just did here. We're predicting her score was 77. Now if I was Professor Krugman and you were Julie, not only should we both be unhappy for a paper being lost, but beyond that, what about this part right here? Yeah. Given that r equals 0.5, do you expect the prediction to be accurate? Why? Well, accurate doesn't mean 100% accurate, but in other words, should we think that 77 is pretty darn close, and that that's what Professor Krugman should put in the book? What do you think? Cheyenne, why not?
I don't know, because she could have studied more, so she could have done better on the exam.
Okay, but think about the statistical information we have here. What does r equals 0.5 mean?
Output.
No. Chapter 4 and 5. What does r equals 0.5 mean? What's it mean when the absolute value is bigger than 0.8 or equal? What one word describes the association? Strong correlation. Okay. This next one is moderate. 0.5, that's between 0.3 and 0.6. That one we said was weak. So there is some connection between the total going in and the score on the final, but in this particular case, it is weak. I've actually found with the statistics class, and a lot of classes I teach, not all, usually I can tell what people are going to have by what they have after exam 3. It's not totally guaranteed though. So the correlation I would find in my statistics class is probably higher than 0.5. In this case, Professor Krugman's got a weak correlation between the two. I would not trust that as a way of figuring out what number to put in for her. Does that make sense? Okay. Let me look for something else here.
What chapter is that from?
Chapters 4 and 5.
That whole problem?
Yep, specifically 5. Okay. Okay, the other thing I wanted to talk to you about, I don't think we have an example in this list of practice questions. So let me give you very briefly here what if you had to come up with a stem plot, and some of the scores you're seeing, I'm just going to write like 5 of them. Maybe you would have more. Let's say we have those values. maybe as part of a bigger set. And you had to make a STEM plot. Maybe those would be FICO credit scores. Maybe you've seen the Credit Karma commercials. Better change my ink, right? Okay, only a couple people smiled, so only a few have seen that commercial then, or paid attention to it. So what if you had to make a STEM plot involving those 5, or maybe there are other scores as well as that? How many digits are there per leaf? How many?
For leaf?
Per leaf.
1.
1. So in this case, that would lead to a problem, because then we would have a lowest stem of 50. What would the highest stem be? 50 actually meaning 50 times 10, 500.
77.
Okay, so 77 standing for everything from 770, but less than 780. Those are $270 apart. You're grouping 10 at a time that way. You'd have 27 rows, most of which would be blank. Many stems with nothing in there. And although we've talked about this semester splitting stems when things are too clumped up, to split it up, spread it out a bit. Or what we saw Wednesday with a back-to-back stem plot. Here, what if it's too spread out? How could you clump it back together a bit? What we had a reminder on Wednesday. In a histogram, which is closely related, what's the smallest number of groups to have?
6.
4 or 5. 5 or 6 would be okay. And the most? 12. Okay. So this would be way too much. What we could do is round to the hundreds, not for the other parts of the question, like when you're doing calculations, but in a stem plot, we could round these to the hundreds. Or maybe it would be to the tens. It depends on what you've got in there. If I round these to the hundreds, this would go up, this would go down. What would happen to this one? Okay. How about the 701?
Down.
Okay. So now I could have 5, 6, 7, 8. That's still 4 groups, maybe not great, but it spreads it out less than 27 groups. 700s, we've got, let's actually write it this way. These 3, 800s, and the 500s. So it tells us we've got something that's single peaked, and it looks like it's, I would figure out X bar and the mean from the original data to be sure, but I think it's probably skewed left. You can tell that if the mean is less than the mean. It's a little rounding, and you don't have to have something that's quite so spread out.
So you went 650 to 699 with 700, and 750 and down with 700.
Right. Yep. Make sense? What else would you like to ask about then on the practice?
Do you want to do the very last problem, number 16 altogether?
Okay. The one about the sweetened cereals and tooth decay, right?
Yep.
Okay. This should be a lot like Monday and Wednesday's material then. We've got these 2 groups. 42 children who eat such cereals regularly, and 167 who did not eat it either regularly or not at all. And they carry this on for 3 years. Look at the number of cavities. So suppose that the number of cavities in both populations is distributed normally. Maybe quite a bit of an assumption, but even so, we'll go with it. Researchers suspected the sweetened cereals increased the mean number of cavities. Besides normal distribution, What else do we need to know? There's something we won't know. Not mu for either group. So that we wouldn't be talking about inference then. And realistically, to have such information, you'd have to have small populations. If you want to talk about the kids that eat only Life cereal versus the kids that eat Cocoa Pebbles, you're talking about millions of kids in each group, just in the United States. And we won't know sigma either. We're talking about T procedures here. What should we know though? Don't know mu, don't know sigma for either group. Independent as part of it. Okay.
Someone slapped me.
Okay, independent what? I would give partial credit for that, but what has to be independent?
Sample?
2 simple random samples, 1 from each population, selected independently of each other. So, for example, if they had conducted this a few years ago and had it so that my brother and I were in there could have been other things besides what if my dad made me eat the Cocoa Pebbles and my brother could only eat Life cereal. There could be genetic things, like maybe my mom had bad teeth. So independence, like we select them randomly, we don't want family members in there most likely. 2 from the same family. All right, so simple random samples from each population selected independently of each other. Part B. Assume that we had that case, simple random samples independent of each other.
So that's all that answer would have to say.
Yep.
Simple,
Simple
random
samples.
samples, independent of each other.
Right. So we want to do a hypothesis test in part B, where alpha is going to be 0.05 or 5%. The hypothesis test being either there is no difference between the population means. Another way of saying that would be that mu1 equals mu2. Well, how do we write it with a subtraction? mu1 minus mu2 would be what?
0.
0. Okay? That's saying no difference. There's 2 different types of cereal. One does not promote cavities more than the other, is what that would be saying. We can look at stuff like that now and say, at this point in time, that's probably a silly stance to take, but decades ago, 70 years ago, 100 years ago, when they started to have these huge food plants that would give us this pre-processed food, yeah, we had known for a while what sugar does, but we didn't necessarily know for sure, what's this particular sugary cereal gonna do? But then, here you go, 80, 100 years and get some experience, and maybe now we wouldn't even try to do that test. So what I'm saying is, if you look at that going, why would we even set that as the null hypothesis? At some point in time, not too long ago, we didn't know. And so we had to act as if the other was the outstanding claim, that the sweetened cereals, the sugary cereals, would increase the mean number of cavities. So if I make, well, here, increase makes me think of greater than 0. Which group am I calling population 1 then?
The one that ate the sugary cereal?
The ones that are getting to eat the sugary cereals or sweetened cereals. Okay? One-sided or two-sided?
Uno. One side.
One-sided. Remember, what you say here, I'm not so much watching for, it's what you do later. Are you looking in the right spot on the percentages at the bottom? Or in a one-sided test, as you remind me, a two-sided test, if you do normal CDF or TCDF, on the calculator, multiply by 2. Here I would not be multiplying by 2 if I go that route. Okay, what else do we know? We're going to need, according to the formula right here, you can't quite see it when I do it that way. There. All that's saying is difference in sample means over standard error, which is not much different than what we've been doing before. It's just calculating standard error is a bit messier now. Since we said let's call this population 1, then population 1, let's see here, actually matches with what we have here, group 1 that eats this sweetened cereals regularly. X bar is 341, x1 bar minus x2 bar. 3.41 minus 2.73. No. 0.68, is that right?
Sure.
No, I'm not trusting myself here. Caffeine's wearing off. Yes? Yes? Anybody else confirming? 0.68? Okay. All right. And as for our standard error, remember only the numerators of the fractions are getting squared. Your standard deviations from the samples, that's what's squared here. Now let's say you get group 1 and group 2 reversed. There's a sort of symmetry to this formula where in the second part here, it's not going to matter. And it also shouldn't affect too much of the rest of it. It's just if you get a negative t-score, I'd get a positive t-score or vice versa. Okay, what do we have here? What's S1, S2, N1, and N2? 1.28 squared over what?
62.
62. That will get added to, all right, somebody else. What am I squaring in the second one?
1.17.
1.17, and that'll be divided by 167. Sample size there. Okay, I forgot to open up my calculator on there. So tell me everything the calculator's giving.
The answer to it?
Uh-huh.
3.6544.
This part
Oh, my bad.
for the standard error. I'm expecting something pretty small.
0.18607206224.
Is anybody else getting the same? That's in the range of what I would expect. Because we're squaring small things, dividing by fairly big things, etc. So, Abel, you're backing it up. Anybody else backing it up? Okay, 2 more. Okay. All right, so let's divide. That's our numerator. Let me see if I can keep it on this side of the board. So T, the x1 bar over our standard error, x1 bar minus x2 bar, that is. That's going to be the 0.68 divided by this messy thing. And once you've done that division, that's when it would be appropriate to round T to 3 places? You were saying 3 point something. What did you get to 3 places?
It's 3.654.
Okay, what was after the 4?
Another 4.
Okay. Now, the reason why sometimes I say round to 3 places or to 4 places is, believe it or not, sometimes if I say to the hundreds, how many places after the decimal point is the hundreds place? 2. And yet either people aren't looking at the direction, or there must be enough people, and I don't just mean this class, I mean lots of classes lately. Either they're not reading the directions, or they don't know what the hundreds place is. So that's why on the last homework I said round to 4 places. I meant 4 places after the decimal point, i.e. to the 10,000ths place. Okay, anybody else back this up? What do we need to do before we look up stuff in table C? What do we need to know?
Margin of error? No?
Not margin of error, that would be for confidence interval.
Yeah, degrees.
Degrees of freedom. How many are there?
61.
Anybody back that up?
My second motion.
2 for 61. 3, 4? Dakota, what is he doing to come up with 61?
Just taking the samples, the minimum, both the samples, minus 1.
Actually, that would work, because if you subtract 1 first and then take the minimum, you'd get the same thing every time. Okay, did everybody catch that? Subtract 1 from each sample size. Take the smaller of the 2. All right. This came up on the exam as well. I don't think there's anything in table C for 61 degrees of freedom exactly. So once I bring this up, I thought I had left this open, but apparently not. Oh. Yeah. Table C. Here we go. Table C. Yeah, 61's not on there, so what do you do?
Go to 60.
Yeah.
Go to 60. Because whatever 61 would give you, 3.654. It's actually bigger than 3.460, the biggest in the row. Well, whatever you would have for 61 degrees of freedom would be somewhere in between these 2. And so if you go up a row, that's a smaller sample, smaller degrees of freedom, bigger T stars, being more conservative. If we had talked about margin of errors for a
I
confidence
just called it
interval,
wrong, I knew what we were looking for.
okay,
I didn't.
but it's worth bringing it up now. If we were doing a confidence interval, it would give you a bigger margin of error, wider confidence interval, so that you've got a better chance of capturing mu. Similarly here, we don't want to reject H naught too quickly. So we're going to 60. And that value for T is already bigger than the biggest thing in that row. We've got 3.654 greater than 3.460. What's that tell us about a probability then? A one-sided P. I think you're showing something in the air. What are you trying to describe?
No, I was just wondering where you wrote it on the board.
Part that I've almost boxed off. So I'm also trying to make it clear for the camera. So the fact that 3.654 is greater than everything in that row, what's that tell us about a one-sided P? Don't answer that yet.
Smaller. Smaller.
Don't answer that yet. If we use the calculator with TCDF, we can say what P is equal to, or nearly equal to. Here we have an inequality. How does P compare, when I went down from that value, T, how does it compare to 0.0005 from the one-sided P row? Okay? Yep. P should go along with this. 3.460 traced down to that, so it is less than. It switches the direction of the inequality. That's less than alpha. That's not 5%, it's 0.05%. Now think it through. Some stuff some people wrote on the test, which, well, it's the first time you had a full-blown test on this material. And if you got marked wrong there for what conclusion to draw, let's try to fix that. Think of the logic here. That 3.654, not only is it way bigger than anything in that row, that means that it's pretty extreme.
So why are you saying it's less than the .005? Why did you change the sign?
Because as we go to the left to right here, with T stars for any degrees of freedom, or for Z star, what's happening at the same time to the one-sided P's and the two-sided
They're
P's?
getting smaller.
They're getting smaller, which leads me back to this point. To have such a small probability, you had to have something pretty extreme. I'm putting this on the right because it's positive, bigger than 0, after the standardizing. So maybe we're way out here in a tail. That's extreme, unique. It's like Sheldon Cooper claiming that for those of you that watch The Big Bang Theory, I have an IQ that's not even measurable by standard IQ tests. He's talking about having an IQ of more than 180. Would you, well, when something's that extreme, what's the likelihood that there's no difference between the two cereals and whether they have a difference in the cavities they cause? When it's extreme. Do you believe this? Or do you believe this? It's like the eye doctor. Do you believe this? Believe this? Switch the lenses back and forth. This. It's extreme. Which one should you probably be going with? Which one? Okay, so we would say reject H naught. When P is less than or equal to alpha, that's because you have something extreme, very unlikely. That's when you would reject H naught. And if you have to put it in the other phrasing, you have significant evidence that these sugary cereals or sweetened cereals do increase cavities.
Reject H.
Nope, H naught. H naught is being rejected, which would point me in the direction of saying, well then HA, I've got significant evidence for it. Alright, so this is something we've said a few times now. Real quick then. Something like that may only be out of, say, a 15-point question. It might only be 1 or 2 of the points making that decision at the end. Really, that's just to make the scoring easier for me. In terms of the importance, maybe I should do something like make it worth 4 of the points, in case some of you are using this later. But I'm trying to make something that's quick and easy to apply and consistent. So, If you're one of those people that's had it reversed on the final, I'm sorry, on the exam 3, every time I said fail to reject H naught, you said reject H naught. Take a look at that, look into the logic in the book. Look into, say, some YouTube videos that try to explain it, or some websites that just explain it in text, okay? Good luck, I'll see you Monday, what time?
1 o'clock.
Alrighty.
That's great.
I think maybe I missed a copy.
Blazing glory all together.
I asked him
Yes,
about
I
these.
just copied.
Are we?
186.
I got the last.
See, that's almost,
I got 18
That's
out of 20,
almost-
you got 18 out of 13, you got
That's
20 out of 13, you copied my paper word for word.
so getting a 3 point something.
I know. You copied
I just copied it, is what it was. Question?
Do you understand that? I did.
60? Because again, 61's not on there.
Why did you do 99?
Oh, I didn't pick that. Here, let me bring the screen back here. It wasn't a choice. It was based on, if you understand why we're using 60 degrees of freedom, we're trying to compare the T that we got to one of these T stars, either to put it in between two of them right next to each other, or else it's bigger than this, or smaller than this. And by the way, if you put in TCDF, this is bigger, so shade to the right, 10 to the 99. Have you tried using normal CDF and TCDF before? Okay. Do you remember what the last thing you need is for TCDF?
Degrees of freedom, so it'd be 60.
Actually, we can go to 61 on this one. Okay? You should similarly get something very small. What we're doing then, I didn't choose that column. It's because my T came out bigger than this T star. Trace down to the one-sided P with that T star, and since that would match up exactly with P equals 0.0005, a more extreme value of T, like that one, should have even less of a probability.
So 0.005 is probability.
Yep.
And since it was less than, you rejected it?
Since that is less than our alpha, our probability is less than this is less than our alpha, that's why we're doing yes. Alright. Holly, did you have any questions?
Yeah, just a real quick question. To find the correlation R, is it somewhere in the calculator or is there an actual equation?
There is a formula, but we didn't cover it. It's in the book in chapter 5, I think it is, either 4 or 5. But yes, you can get it from the calculator.
Okay, can you show me real quick?
Do you have some data in there right now?
Yeah, I have. It's the same problem that I had trouble with.
Okay.
It's all in there. So.
Okay. So let me just take a look at it. I think the fact that the graph you must have the right number in it. Yeah, you've got the same number in there. Then you go back to stat and calc. This is the fourth option. Tell it the x's are in list 1, comma, y's in list 2. And if you also wanted to graph, one more comma, bars, y bars, press enter a few times, it'll put y1 there. It saves the equation. If you press y equals in a minute, it'll save the equation, and when you regraph it, it'll have the line in the scatter plot. The R is right there. Okay? Not R squared, but R is the bottom. And here's the graph with the line along with it too. YouTube videos will remind you of that stuff if you forget before next Tuesday.
And wasn't R squared something?
It stands for the percent well, if you convert your decimal to a percent, how much of the variation is being explained?
Okay.
How much of the variation that we see in Y is explained by the variation in X?
Will that be asked on the test, do you think?
If you see one like that on the sample final, then most likely yes.
Okay,
Okay?
thank you.